In college algebra, we started chapter 4 today over exponential and logarithmic functions. Right there we have an example of the basics of an exponential function, and that's where we have some number b, a positive constant other than 1, and x is any real number. So number 1 right here is an example, a real-world example. It's kind of a sad example of an exponential function. In this situation, we're looking at O-rings on the space shuttle, the Challenger, that ended up not making it. So they had this function here to predict number of O-rings that would fail, and if an O-ring failed, the shuttle would fail. On the day that it launched, it was 31 degrees, and that is what X symbolizes, is the temperature that day. To do this, we're going to plug in 31. Be careful when you type it. Make sure you use parentheses. Your calculator will do the order of operations correctly. I'm going to put 31 in place of X. That's why it's an exponential function. Anytime you have X in the exponent, that's why it's called an exponential function. All right, we can't do that in our head, or I can't. So let's jump to the calculator. I'm going to type 13.49. I've already forgotten what it was. 967. Use a parenthesis. Close the parenthesis. This here in red is the exponent button. We're raising it to the 31st power. And be careful, notice in our function up here there's a -1, but that -1 is not in the exponent. If I just type -1 without moving the cursor, it is up in the exponent. So after typing 31, you need to hit the right arrow and then -1. And we got it, 3.77. All right. So this was a tragic situation because the shuttle didn't make it. And I'm wondering how much of this knowledge they knew beforehand. But that's a good real-world example. Number 2, we're just going to practice graphing. I typically like to pick 0, because that's a nice central point, and then some numbers to the left and to the right of it. I'm going to pick -3, -2, -1, 1, 2, and 3. Some of these we can do in our head, but some of them not so much. So I'm going to go to the calculator. Oh, by the way, let's keep going actually so I can show you why I'm going to type what I'm going to type. Remember, that's X. All those blue numbers are X. So I'm going to raise 2 to the -3rd power. I know 2 to the 3rd power is 8. But remember, anytime we have a negative exponent, you move it to the denominator. Whoops, I already messed up. Which is 1/8. But let's look at how the calculator does it. It does all the work for us. So one way is to go to the blank screen, 2 exponent -3, gives us a fraction. If you don't want a fraction, I like to just type a decimal in my typing, and it forces it to give you a decimal. So since I typed a decimal after the 2, I don't know, I feel like it's a tad faster to get it that way. An even faster way is to click on your graph. Let's type 2 to the x power. And there's a picture of what we're about to graph. and then press Control T, and you have an infinite table. So many choices of what you decide to plot. So 125, 25, 0.5, and the rest we can do in our head. Let's go back. So we have 0.125, 0.25, 0.5. All right, these we can do in our head. 2 to the 0 power. Remember, anything to the 0 power is 1. 2 to the first power is 2. 2 to the second is 4. And 2 to the third is 8. And you can imagine this starts to get out of control as we increase the value of x. Let's plot those points and just plot them as close to the x-axis you can for these two. And then it slowly drifts away from the x-axis, and then all of a sudden it takes off. If we picked one more x, it would not make it on this grid. And there's our graph of our exponential function. That's typical of what they look like. It'll be really flat and then increase rapidly, or vice versa. Maybe it's decreasing rapidly and flattens out. But that's the function for 2 to the x. Down here, we're just going to practice our transformation rules, very similar to what we did last semester, except we have an exponent now. Some people struggle with this b and c thing, so instead of c, let's write a real number. So let's treat c like a 4. And we can describe it a little easier. If ever it's added after the exponent, but not in the exponent, it's going to move it up. So up 4 units. If it's subtracted, that's down 4 units. If it's in the exponent, you got to think backwards. We go left, struggling with writing, 4 units. On the next one, since it's minus, we're going to go right 4 units. If I throw a negative on the front, that flips it over the x-axis, so I like to write flips down, or you can be more specific, over the x-axis. If the negative is in the exponent, it flips over the y-axis, or I just say flips left over the y. And lastly, if we have a c, a front number, if c is large, if it's larger than 1, then it climbs faster. Or steeper, because I'll be multiplying by a big number. If it's small, like a small decimal between 0 and 1, like 0.5, 0.2, then it climbs slower. You know, I typed shrinking. That doesn't really happen, but it's less steep. I know that's true. And if you forget these rules, the nice thing is you can type them on your calculator to check them. To clear out any graphs, press Dock B, we have 2 to the x. Move the cursor out of the exponent, plus 4, and it's up 4. If you press the tab button and then up, you can alter what you had. So if I go minus 4 in the exponent, it's going to move it right. Tab up. And let's make this negative flips down. You can type in any combination of these you want. And that was it on Thursday. See y'all later.